Hello, hello. Welcome to our next episode of No Lids, No Limits. I'm Kin, again here by myself as Arik is still on the road this summer, traveling through parts of Europe. So I got asking AI a few questions about all the lessons we've learned this past year on our podcast. And it actually came back with some pretty good conversation. So I'm going to start you off with a segment which I asked our Gemini notebook about our past episodes to see what the AI has learned about our podcast. Here it is.
Ken Leong has spent over 30 years managing manufacturing operations, balancing the constant pressure to deliver better, faster, and cheaper products. By 2026, that balancing act has reached a breaking point. Canadian factories are caught in the crossfire of international trade wars and supply chain shocks, all while facing a massive shortage of skilled tradespeople. This chart shows the crisis in motion. As the demand for production continues to climb, the available human labor pool is in a steady decline. Simply ordering current staff to work harder is breaking the workforce. To survive, factories have to look past the traditional definition of a floor worker. The industry has relied on high-speed, rigid automation for decades. These machines are perfect for repetitive, high-volume tasks that follow a pre-programmed path. However, legacy robots fail when the work becomes unpredictable. They cannot handle complex box builds, custom troubleshooting, or the nuances of physical quality control. These unstructured tasks require a level of physical adaptability that has, until now, been a uniquely human trait. Solving the labor shortage isn't about finding faster tools. It requires machines that can navigate the messy, unscripted reality of a modern assembly line.
So the AI's figured out that in the manufacturing environment, robots aren't quite ready to replace our human workers at this moment. However, that's not to say that robots, perhaps coupled with artificial intelligence, could not replace the supervisors or the engineers or even management. So here's where the conversation may take us.
Elevating a robot into a management role sounds like a dystopian pivot, but it may actually be the psychological intervention these stressed factories need. In 2026, a surge of new humanoid robots began hitting the commercial market. Most were not designed for factory-grade precision. Instead, their joints and sensors were engineered to navigate the unpredictable environments of a family home, climbing stairs or folding laundry. This comparison highlights why that domestic origin matters. While a rigid arm is locked into a fixed axis, the humanoid skeleton has the multi-axis freedom to step around obstacles and move through floor plans designed for people. Despite this physical agility, these machines arrive as blank slates. They have no innate knowledge of electronics assembly or complex production workflows. Physical adaptability is a hollow asset if the machine lacks the tribal knowledge of how the factory actually functions. While the hardware evolved, AI became a highly capable digital intern, processing vast amounts of operational data in seconds. However, feeding confidential engineering specs into public AI models is a massive security risk, potentially exposing proprietary designs to the open internet. The solution is the local AI model. This closed-loop brain learns only from approved internal manuals. All information is safeguarded within the company server, isolated from the public internet.
That's a very interesting conversation that the AI has taken us and exploring this idea that the local models should be run instead of a shared public model like the frontier models we often use with our ChatGPT or Gemini or even Claude. So, what are the advantages of running a local AI model? Let's have a listen.
We're going to explore how deploying highly capable, localized OpenAI models, and I'm talking specifically about models like Zipu or Gwen, allows you to build a totally secure, offline company brain.
So here's our game plan for today. First, we'll look at AI as the smart manufacturing intern. Then we'll tackle the public AI privacy trap. Third, we're comparing frontier versus local models. Fourth, building the company brain. And finally, the shift from data, knowledge, and wisdom. Let's get right into it.
Section 1. The Smart Manufacturing Intern. To kick things off, we really have to completely reframe how we even think about artificial intelligence on the factory floor.
The absolute most crucial point here is that we've got to stop picturing some kind of robot overlords coming to replace your seasoned floor managers. Instead, picture a highly capable assistant who is just ready and waiting to handle your heavy data lifting. Now look, operations managers are naturally skeptical of tech buzzwords, and honestly, rightfully so. You've probably seen decades of software promises fall completely flat. But industry veteran Kin Leong hit the nail on the head. He notes that we need to view AI exactly like this, a super eager, incredibly fast intern that you're onboarding to take over the busy work.
Because look,
These are your low-hanging fruit. This is literally the 80% of repetitive administrative busywork your new intern can wipe out today. Think about it. Instead of your team spending half a day agonizing over a highly technical sales email to a client, the AI just handles the first draft. Or instead of a junior analyst digging through, thousands of rows of IoT sensor data, the AI instantly spots a microscopic anomaly showing that a machine on the surface mount technology, or SMT line, is falling out of calibration. Because it understands what an SMT line is supposed to output under perfect conditions, it flags the issue way before you accidentally print a batch of defective circuit boards. It just clears out all that administrative noise so your human talent can actually focus on real problem solving. Section 2. The Public AI Privacy Trap. Now, before you go handing over all your sensitive manufacturing data to this fancy new intern, we need to have a serious talk about a major operational hazard. And this brings us to what folks in the industry call the scary thing. You've got massive amounts of confidential data floating around your facility, right? Customer bills and materials, proprietary NDAs, complex pricing structures, deeply guarded client schematics. The terrifying question is, are you accidentally leaking them? See, when you use mature frontier models, the big public AI chatbots that everybody and their mother uses online, your highly sensitive, NDA-protected data gets sent out to external servers. And it's entirely possible that your proprietary client data is then being used to train that public model. Imagine for a second an aerospace contractor accidentally feeding a highly classified part schematic into a public chatbot, just trying to optimize a machining toolpath. Poof. That competitive edge, and more importantly, that client trust, is potentially leaked right back out into the public domain. In North American manufacturing, where your intellectual property and your secure supply chains are literally your lifeblood, breaking an NDA like this is a catastrophic risk. Section 3. Frontier versus local models. Which brings us perfectly to the vital difference between using those massive public models and deploying secure, local, open models. Let's break down the trade-offs here. Frontier models? They're fantastic generalists, they have vast internet knowledge, but they come with a high reliance on really expensive cloud compute, plus those massive security risks we just talked about. On the flip side, we have local, open models like ZPU, Gwen, or maybe local Anthropic deployments. These things are walled off. They live entirely on your hardware, totally disconnected from the outside world. They basically act as an impenetrable, secure vault for your proprietary data. And get this, running these models locally keeps your compute costs incredibly manageable. Instead of paying this variable, wildly unpredictable tax for cloud API calls every single time one of your engineers asks a question or analyzes a dataset, your local compute costs are fixed and they are dramatically lower. Now, the trade-off here is super simple, but it does require a pretty strict shift in how you operate. Local models are amazing because they perfectly protect your client's privacy, and they train specifically on your company's unique processes to become internal experts. But, and this is a big but, because they don't just rely on the open internet to fill in the blanks, they absolutely require you to provide clean, high-quality internal data to function effectively. The age-old rule applies perfectly here. Garbage in, garbage out. If your floor technicians are logging machine downtime with vague notes like, "Fixed it," instead of detailing the exact pressure valve failure, your local AI isn't going to be able to predict future failures. It needs precision. Section 4. Building the company brain. So once you have that secure local environment set up and your data is actually clean, you get to begin the most exciting phase, building a highly specialized expert for your entire organization. Let's walk through how this happens. First off, you cannot just plug AI into a broken factory. Buying fancy software without fixing your workflow, that just speeds up your existing problems. You've got to use lean principles to clean up your processes and eliminate that physical downtime waste first. Second, gather your accurate localized data. And finally, upload your standard operating procedures and, this is huge, your tribal knowledge. Guys, there is a massive retirement tsunami happening in North American manufacturing right now. Your most experienced Gen X and Boomer experts, the ones who know exactly how to coax a stubborn CNC machine into tolerance literally just by listening to the hum of the motor, they're retiring. You can use your local AI to document and capture that deeply specialized tribal knowledge before it just walks out the door forever. And when you do this, the output is just incredible. Once your localized company brain is trained, it completely democratizes your data. Instead of needing, an Excel wizard or a Python programmer to build complex pivot tables, any floor supervisor can just instantly ask plain English questions. Things like, hey, which station was most utilized last quarter? Or did voltage variations increase on Tuesday? The AI can instantly create visual mind maps from 1,000-page technical manuals, or even generate professional training scripts for your new hires in literally minutes. It empowers every single employee with instant, secure access to your entire company's collective intelligence. Section 5. Data, Knowledge, and Wisdom. But listen, even with the absolute most powerful local AI brain running flawlessly on your factory floor, the human element remains absolutely 100% irreplaceable. And to understand why, we really need to look at the DIKW model: data, information, knowledge, and wisdom. This framework perfectly explains exactly where your local AI intern stops and where true, boots-on-the-ground human intelligence begins. So here's how this actually plays out in real life. Your local AI rapidly handles all the heavy lifting of raw data. It organizes it into information, and it identifies the hidden patterns to hand you knowledge. It literally gets you 80 to 90% of the way there in seconds. But it takes that final 10% of human intelligence to apply wisdom. Because remember, AI operates within very strict logical guardrails. It cannot think outside the box. A seasoned ops manager, on the other hand, takes that AI-generated knowledge about, say, an impending material shortage, and they use their human intuition and their industry relationships to proactively call up a secondary supplier, entirely preventing a supply chain bottleneck. Humans know exactly when and how to creatively bend the rules to get an essential order out the door. We apply empathy, strategic foresight, and pure ingenuity.
So, let's wrap this up. Using local models like Gwen or Zipu gives you the ultimate operational advantage. You get massive analytical power, incredibly low and predictable compute costs, and absolutely zero risk of leaking your client's guarded secrets to the public domain. But remember, organizations that drag their feet on adopting secure localized AI risk falling irreparably behind in efficiency and margin. So my advice? Start utilizing lean principles, cleaning up your processes, and gathering your operational data today. Because honestly, the real question you have to ask yourself is this: if your competitors are training their private AI brain right now, what is your factory floor going to look like tomorrow?
We think about the factory of tomorrow as being something that's really high tech, maybe even a lights out factory, full of robots running around, AI is doing a lot of work. But the reality is, before we get there, or even head in that direction, we got to really think about how our factory works today. What are some of the existing problems that are already manifested within the factory operations? This is where we have to embrace this idea of Lean Six Sigma and fixing some of the basics. Getting rid of the problems and issues, I think, is much more important as a first step before we start jumping on this whole AI and robotics journey. So here's what Gemini has to say.
Here is the hard truth. Before we can unleash AI in our operations and just let algorithms run the show, we absolutely must master the physical factory floor first. Today, we're going to explore why Lean Six Sigma isn't just some old-school operations methodology. It's actually the mandatory prerequisite for your IT and data science teams to succeed. Okay, let's dive into this, because this is exactly where so many companies get it completely wrong. The temptation is to look at AI as a magic software fix for broken manufacturing processes, right? We see a chaotic supply chain or a factory floor with crazy high scrap rates, and we think, hey, let's buy a highly sophisticated AI agent to figure this out. But is your factory actually ready for that? If your physical processes rely on tribal knowledge, paper trails, and just constant human workarounds, plugging an AI into that environment is a literal recipe for disaster.
I absolutely love this quote from our source material. If you slap AI onto a broken process, you don't fix the process. You just start making mistakes faster. We really have to remember that AI is, at its core, a highly efficient pattern-matching engine. So if you deploy AI over an unstandardized, messy process, it doesn't magically fix the waste. No, it simply scales your existing inefficiencies. It learns unpredictable human variance rather than the actual objective health of your machines. And that is exactly what we need to avoid.
Let's start breaking this down in Section 1. The AI implementation trap. And this brilliantly illustrates the core issue. To really understand how to deploy these advanced IT systems, we actually have to step away from the server room for a minute. Think about an unstandardized factory. If you try to run AI there, the algorithm ends up predicting human variance. It scales physical waste and creates complete data chaos because, well, no two operators are running the machines the exact same way. Now compare that to a lean factory. Because the physical processes are standardized, the AI can actually predict true machine health. It optimizes throughput, and most importantly, it generates a clean, reliable data pipeline. So, the crucial takeaway here is that we need to totally redefine what Lean Six Sigma means, especially for all the IT and information systems experts tuning in. You know, Lean Six Sigma is no longer just about minimizing physical waste or clicking stopwatches on the floor. In the age of Industry 4.0, Lean Six Sigma is the foundational physical infrastructure required to generate a clean, predictable digital data pipeline for your machine learning models. Put simply, physical workspace stabilization literally equals digital data hygiene.
Moving right along to Section 2, Standardizing for Clean Data.
What we're doing here is translating physical operations terminology directly into data science language. We've got this prerequisite playbook that maps physical tools directly to their massive digital benefits. It covers everything from standard work yielding clean training data all the way to Kaizen, empowering human-in-the-loop training. Let's break a few of these down so you can see exactly how they work together in the real world.
First up, standard work. In data science, we know that AI models require consistent baseline data to learn optimal machine performance. Think about a CNC machining process. If you allow operators on different shifts to manually override and tweak the feed rates based on their own personal preferences, you're just feeding the AI chaos. By enforcing standard feed rates, you ensure the AI receives uniform baseline data. Now the algorithm is accurately correlating cutting hours with physical tool wear, rather than just learning that Bob on the night shift likes to run his machine 10% faster. Now, what's really interesting about this slide is how a completely low-tech concept like 5S directly impacts high-tech AI. 5S stands for sort, set and order, shine, standardize, and sustain. Let's zero in on the shine step for a second. If your curing oven has temperature sensors that are just covered in industrial grime, your industrial Internet of Things infrastructure is transmitting garbage data. It's that simple. But by physically cleaning and recalibrating, by shining those sensors, you guarantee high-fidelity telemetry. That incredibly simple physical act of wiping off a sensor is what actually allows your complex AI agent to make precise, real-time micro-adjustments to gas valves.
Okay, let's shift gears to Section 3, Mapping Value and Causation. AI is incredibly powerful at finding hidden correlations, but we have to remember it completely lacks an understanding of real-world causation without our help. This is where value stream mapping, or VSM, comes into play. It visually identifies true production bottlenecks so you don't waste computationally expensive IT resources on non-constraints. For example, if you use VSM and discover that manual quality assurance is the actual bottleneck holding up the entire factory floor, well, you know exactly where to deploy your expensive computer vision AI agent. VSM prevents you from needlessly over-optimizing assembly line speed when the real holdup is sitting right there at the inspection station. Next, we have the Ashikawa, or the fishbone diagram. Traditionally, we know this as a root cause analysis tool used out on the factory floor, but in the context of an AI-ready factory, it serves as a literal physical blueprint for algorithm feature engineering. It tells your IT data scientists exactly which variables they need to feed into the AI so the algorithm actually knows what to look for.
Let's move to and see how this builds a perfect AI solution step by step. Imagine you observe scrap rates rising on humid days. You ask the 5 whys and trace the root cause all the way down to moisture-absorbing raw resin. That physical analysis is absolute gold for your IT team. Because instead of letting the AI guess, you direct the data scientist to connect the AI directly to the resin dryer's telemetry. Now the system can automatically adjust drying times based on ambient humidity. The human found the causation, the AI executes the correlation. It's brilliant.
Which brings us to our final part. Section 4, Empowering Human Intelligence.
Because AI is rarely ever perfect on day one, we really need to focus on the day after it's deployed. It requires a very specific operational culture to actually succeed long-term. This is where Kaizen, the culture of continuous improvement, becomes your human-in-the-loop training protocol. You have to treat your new AI like a smart intern. It's incredibly fast, for sure, but it kind of lacks street smarts. Say your AI scheduling agent generates a rapid tooling changeover sequence to maximize uptime, but physically, it's just awkwardly fast for the human operators to execute safely. Now, in a non-lean culture, workers might just roll their eyes and ignore the system. But in a Kaizen culture, operators are empowered to actively coach the AI. They log constructive feedback, IT updates the physical constraints in the software, and your AI intern learns to generate practical, operator-friendly schedules. To bring this all together, we have to completely change our perspective. AI is not a magic software fix. If you treat it like one, it is basically guaranteed to fail in a chaotic environment. Instead, view AI as a highly capable, smart intern. It doesn't replace human workers, it relies entirely on the disciplined, structured environment that human intelligence builds. Without Lean Six Sigma stabilizing the physical world first, your digital intern will just be endlessly spinning its wheels. So I want to leave you with this final, provocative thought to take back to your own operations. Look around your factory floor. Look at your data pipelines and ask yourself, will you standardize your physical reality before unleashing your digital intern? The success of your entire AI implementation depends entirely on your answer to that question.
That seems to make a lot of sense, doesn't it? Application of Lean Six Sigma, particularly 5S and Kaizen, to iron out the existing innate problems with the operations before you go and accelerate and automate everything. Because the idea here is by jumping into automation and application of AI, you're just going to speed up and amplify the problems that you already have. So that makes a lot of sense. But once you have those processes ironed out and you start to roll out the I think it's worthwhile exploring the impact of rolling out such technologies across the human workforce. And this is one area that I think it's worth a conversation. Let's have a listen.
The convergence happens when this secure intelligence is downloaded directly into the adaptable humanoid hardware. Now you have a machine that can read a specific quality manual, walk to a workstation, and execute a bespoke inspection autonomously. This secure data bridge allows domestic hardware to operate with the specialized logic required by a rigorous production line. This technological shift has triggered a surprising psychological change in the human workforce. Human-to-human supervision is often fraught with friction. Managers get tired and biased, and their corrections can feel like personal attacks, which damages team morale. This is where the machine steps in as the non-judgmental supervisor. When a robot identifies a flaw or guides a worker through a correction, it does so with infinite patience and zero ego. There is no emotional friction in the interaction. Removing fatigue and human ego from the feedback loop makes workers less defensive and more receptive to improving their output. This shift allows factory leadership to double down on the one resource no algorithm can replicate: the spontaneous, inventive capacity of their people. Humans excel at creative problem solving. When a crisis hits the floor, humans are the ones who can think outside the box and safely adapt the rules to keep production moving. By letting the robotic supervisor absorb the routine friction of quality checks, the human team is freed to focus entirely on high-value innovation. The hardware and the local data are ready to close the productivity gap. The question is your manufacturing culture ready to report to a machine that never judges you? When you pull back and look at a fully integrated facility, the physical footprint looks largely the same, driven entirely by human operators. What has actually changed is the flow of information. The secure digital brain democratizes the facility's data, dissolving the walls that traditionally isolate the sales, engineering, and warehouse teams. Algorithms handle the high-volume, repetitive analytical lifting that usually bogs down daily operations. Offloading intense data processing gives the human workforce space to apply agile, creative thinking to complex engineering problems that machines simply cannot solve. Resilient manufacturing thrives when innovative humans are empowered by a secure digital brain.
So, do you agree with the take that Gemini's figured out through the lessons learned over this past years of podcasts? The idea that the humans need to work alongside the AI and the AI has to rely on the humans for the innovation and creativity and that out of the box thinking. I think I really subscribe to that idea myself, and I'm starting to learn a lot of this perspective in my current work right now. I'd like to hear what you think about this idea. So drop us a comment or your thoughts about this topic, and we always like to hear from you. So until then, thank you very much for joining us for another episode of No Lits, No Limits, and we look forward to talking with you on the next one. Thank you.